So today we're continuing on in our notes on the one-to-one functions and inverse notes. And we just have a couple of examples to finish. So this is part 2 of the video. And what we're going to do to start is we're going to find the equation of the inverse of f of x equals x squared plus 3 if x is greater than or equal to 0. So we have a restriction right now. And then we have to state the domain in the range of both f of x and the inverse of x. Remember that notation f to the negative 1 of x means inverse. And then we're going to check the result in a few minutes. Well, first of all, let's take a look on our calculators. What does x squared plus 3 look like? So we go to y equals, we type in x squared plus 3. And if we graph it there, we get this picture. But we have a restriction on it. It says, as part of the problem, if x is greater than or equal to 0. So this picture is not completely representative of what we're going to draw on our graph. It might be helpful to go to the table. We go to second and graph and look at the table. Mine defaults to starting at 0 and it says x is greater than or equal to 0. So these are the values that are showing up on my table right now that we would use. 0, 3, 1, 4, 2, 7, and so forth. And in fact, on those first 3 points, that's what I'm going to graph. So again, if we look at our table here, what we've got is we've got 3 values that we can graph. We've got 0, 3, and we have 1, 4, and 2, 7. So 1, 4, and 2, 7. So let's draw that on our grid here. Over 0, up 3, 1, 4, 2, 7. There's more points, as we could see in the list of our table, but those 3 happen to fit on our graph there. And if we draw that part of the graph, we get this picture. And we do need to figure out what is the equation of the inverse. But we can revisit this topic that we did yesterday, which is, well, what is the basic relationship of inverse? And the relationship of inverse is that we, darn it, to get the values there, won't work now, good. For inverse, 3rd time's a charm, the x and the y value switch. So when we graph our inverse, we can graph 3, 0, 4, 1, and 7, 2. So we can already get the picture. 3, 0, 4, 1, and 7, 2. And there's our picture. Remember that these graphs should be symmetric over the line y equals x. And the line y equals x starts at the bottom left corner and goes to the top right corner. So a mental check is that if we fold this kind of lilac graph over that red line, we'll land on this line, on this curve right there. And it should. So now the question is, what is the equation of this graph? And remember, when we calculate out that value, f of x is y equals x squared plus 3. To solve this, what we do is we switch x and y. only switch the values of x and y. X goes where y went, y goes where x was, and that squared now is on to y. We only switch the x and y. Our next step then is to solve for y, so we're going to subtract 3 from both sides. And we get x minus 3 equals y squared. And finally, the inverse operation of squaring something is taking the square root. So let's square root both sides. So our inverse is the square root of x minus 3. And I'm going to write that with the inverse notation. So this equation, the square root of x minus 3, is what's in that lilac purple color. That's the equation of that chart. Now, we need to find the domain and the range of these. And so when we go back to the original function, here, the nice part is, if we're really thinking about it, domain is represented by the x variable. So our domain in this function is given to us. That's what that restriction was at the beginning of our problem. X is greater than or equal to 0. By the way, we can write that in interval notation as 0 to infinity. Those two statements there mean the same thing. When we're looking at the range of a function, I oftentimes say, do we have a high point or a low point on the graph? Well, when we look at the darker purple graph, we actually have a low point. It is at the lowest value there on our graph, which has a y value of 3. I didn't say that very well. Our range is y is greater than or equal to 3. 3 is on the graph, and it's at 3, and then it's everything above. And again, just as an aside, in interval notation, that would be 3 with a bracket to infinity with a parenthesis. The bracket means that it is included. The bracket means it is included. So now, we need to look at our domain of our other function, our domain and range. But if we go backwards here for a moment, remember what happens here. To find the domain and the range, find the domain and the range of an inverse, the domain became the range of the inverse, and the range became the domain of the inverse. Do we really need to do any extra work over here? Hopefully not. Hopefully you will see that our domain of our lighter purple graph is going to be x is greater than or equal to 3. And our range is going to be y is greater than or equal to 0. Now, I did switch the variables, because domain is represented by x and range is represented by y. But the values were still the same. We started at 3 and we went right, and 3 was part of it. Our lowest value on this graph was 0, and then we go kind of up. Y is greater than or equal to 0. So now that we've got that, we've got the domain and the range, we need to check. And I know that it's kind of a bad word, but what we're doing when we check is we're really proving that these are inverses. It's just a little bit different kind of proof from what you did in geometry. I'm going to write the functions down again so I can see them, and hopefully I didn't just do something wacky, but I did. Darn it. So the functions are, the original function was f of x equals x squared plus 3. And the inverse function is f of x, or the inverse is the square root of x minus 3. So now we're going to look at the composition of these. And first of all, we're going to do f of the inverse function. So our f function, and then our inverse. Our inverse is the square root of x minus 3. What we're going to do is we're going to take that value and we're going to put it back into our f function, which is x squared plus 3. And the value that we're putting in is the square root of x minus 3. So we're putting that in here. So we get x minus 3 square root of x minus 3 squared plus 3. Well, square rooting and squaring are inverse operations. They cancel each other out. So now what we're left with is we're left with x minus 3 plus 3. And what does x minus 3 plus 3 equal? X. And that's what we want it to equal. But not only do we have to go that direction, we need to go the other direction. We need to figure out, well, the inverse of the original function, which is the x squared plus 3. We're going to take that value now. We're going to put it back into the square root of x minus 3. And it's the purple value that's going to be replacing the x value in the square root of x plus 3. So it's going to go in here. And don't skip steps, because remember proofs, you don't want to skip the steps. Ritzy? Sign off. Press. So now, what happens is we've got x minus 3. Darn it. Let's try that one more time. Square root. And then it's going to be x squared plus 3. And then we have minus 3. Again, don't skip steps. It seems like it's trivial, but it's not. So we put that value in for x. Our next step here in the simplifying process is we have to take 3 minus 3. When we add those together, they give us 0. And now we're left with x squared. And then finally, what we need to do, square rooting and squaring are inverse operations. The square root of x squared is x. And what happens when we end up with x for both values is that we have proved that the inverse, that these two graphs are inverses of each other. And if you look back in the problem, it says check the result by showing that f of the inverse function equals x and the inverse of the original function equals x. Both of them we want to equal x. But as we finish here with our last example, all that we have to do on this one, luckily, is we have to find the inverse of the function. So we don't have to do the checking, although we could. But we're going to keep it a little bit simpler here. But what we want to look at is the fact, first of all, that this is y equals 2x plus 1 over x minus 1. And when we're dealing with the inverse, we're switching, we're interchanging, we're reversing the x and the y. But we have more than one x in this problem. So what that means for us is that all of the x's have to have a y when we replace. So x is going to replace the y. But over here on the other side, then we're going to have 2y plus 1. And we're going to have y minus 1. So we had to replace all of the x's with the y's. So now we've got this fraction. We need to get rid of the fraction. So what are we going to do? We're going to multiply both sides of the equation by y minus 1. Multiply the right side of the equation by y minus 1. Multiply the left side by y minus 1. And it's going to be the entire side there is going to be multiplied. And I'll fix that symbol there. Y minus 1. There we go. When we multiply both sides by y minus 1, the y minus 1's cancel out. So we've got, then, over here, y minus 1 times x, just to write it a little bit neater, equals 2y plus 1. And now we can solve. We're going to distribute over there on the left side. So we get x, y minus x. And on the right side, we've got 2y plus 1. Remember, our goal is to solve for y. And we have a y right now on the left side of the equation. We have a y on the right side of the equation. We need to get them on the same side. Do you have any preference in terms of the side? Me neither. So, in general, I tend to move my letter to the left, of what I'm solving for to the left. So I'll move the 2y over here. And if we move the 2y over there, then let's move the x over to the right side. And that leaves us then with x, y minus 2, y equals 1 plus x. But we still have two y's in the equation. I wonder how we solve for two y's in the equation. And that would be that we can factor the GCF on that left side of the equation. Our GCF is y. And then we only have the y written once. So now it's y times the quantity of x minus 2. So our opposite operation is to divide by x minus 2. And when we do, what we just found is our inverse of 1 plus x divided by x minus 2. Remember that this is the inverse. I usually write both of them. And there we have it.